You've been there, right? One minute you're working away, the next it feels like half the internet has just vanished. Your apps are down, your favorite sites won't load, everything is broken all at once. It's this huge shared frustration we all have, and today we're going to pull back the curtain and figure out why it happens.
So what is going on? Why does it feel like the entire internet can just break at the same time? Well, as it turns out, it's not just a feeling. Our digital world is built on this incredibly complex web of dependencies. So a single failure can set off a massive, cascading chain reaction.
The absolute best way to picture this is with the classic domino effect. See, the internet isn't just one big thing. It's a huge collection of services that all rely on each other. So when one of those services, one of those dominoes, topples over, it can trigger what's known as a cascading failure. And for the engineers trying to keep everything online, that is the ultimate nightmare scenario.
So to really get what happens during these outages, we're going to look at them through three different lenses. First, the cascade itself. Second, why you have to look at multiple layers to find the problem. And three, the clues that are hidden in the timing of it all. Let's put these ideas to the test with our first case study.
We are starting with a giant Amazon Web Services, or AWS. This is the cloud infrastructure that powers a massive chunk of the internet. We're talking services you probably use every single day, like Slack and Snapchat. So when AWS has a bad day, pretty much everyone has a bad day.
And this was a very bad day. The whole disruption lasted for more than 15 hours. 15! In internet time, that is an eternity. It just gives you a sense of how deep this problem went and how incredibly hard it was to untangle.
Okay, now check out this timeline, because it's fascinating. The initial problem, a DNS failure, was actually spotted and fixed pretty quickly, by 9:25 a.m. But look what happens next. For nearly 12 more hours, other systems just kept on failing. They put the first domino back up, but the rest of the line was already tumbling down.
So what was that first domino? It was a weird little thing called a race condition. The simple way to think about it is like this. You have two automated systems that normally work just fine by themselves. But in this one super rare sequence, they tried to do something at the exact same moment, they conflicted, and it produced a totally wrong result. This tiny, rare bug was the spark that started it all.
And that spark lit a huge fire. The initial DNS error caused so many problems that even after it was fixed, the systems downstream just couldn't recover. Things like server management and load balancers, which need the core system to be healthy, started failing because they were completely overwhelmed by that initial chaos. The cascade had literally taken on a life of its own.
So the big takeaway here is that outages in the cloud are just incredibly complex. It's never about flipping one switch back on. You have to be able to see everything from the deepest network layer all the way up to the application the user is actually clicking on. A problem in one place can easily look like a problem somewhere else entirely.
All right, let's move on to our next case. This one is a totally different kind of puzzle. We're talking about the big YouTube outage, a time where all the internet's roads were clear, all the lights were green, but you still couldn't get to your destination, actually watching a video.
This outage lasted for about 90 minutes, and it affected pretty much anyone on the planet who was trying to watch a video. So it wasn't as long as that AWS mess, but how specific and global it was makes it really interesting.
And here's what was so weird about it. The YouTube website itself, it was working perfectly. You could browse around, you could search for things, you could see all the thumbnails, but the second you tried to do the one thing YouTube is actually for, playing a video, you got nothing. This tells us the problem wasn't with the whole system, but with one very specific, very critical piece.
So the investigators could immediately rule out all the usual suspects. It definitely wasn't a network problem because the rest of the site stuff was loading just fine. And it wasn't an authentication issue because even public videos that don't need a login wouldn't play. The problem was hiding somewhere much, much deeper.
All the evidence pointed to a failure deep inside YouTube's application layer. Some back-end service, something a user never even sees, that handles the complicated job of putting together and delivering the video stream, had failed. The roads were fine, but the factory that actually puts the cars on the road was broken.
This case is the perfect example of our second big idea. A healthy network is not enough. You have to be watching the actual user experience. Can people do the one thing your service is supposed to do? This outage shows that while you can contain a failure, you absolutely need to be able to see into those hidden application layers to know what's really going on.
All right, our last case study zooms way in on a much shorter, much more precise kind of outage. This is what happens not deep inside a cloud provider, but right at the seam where two massive networks have to shake hands. In this case, it was between the provider AT&T and the cloud service Microsoft.
This whole thing only lasted about 30 minutes. I mean, compared to that 15-hour AWS saga, it's just a blip. But it's how precise this failure was that makes it so important.
Let's just look at the evidence here. The outage only, and I mean only, affected users on AT&T's network. If you were on any other internet provider, Microsoft 365 worked perfectly. And the data showed that traffic from AT&T was getting to Microsoft's front door successfully, but then it was just disappearing right after it got inside. The problem was precisely at that handoff point.
The lesson here is all about those interconnects, the seams where different networks meet up. This is a classic point of failure. Being able to pinpoint packet loss right at that handoff is what let engineers fix it so fast. It also kept the problem contained to just one provider, which stopped a much bigger domino effect from happening. Okay, so we've looked at a huge internal cascade, a hidden application failure, and a really specific network glitch. Let's zoom out now and see what the bigger picture really tells us. The analysis these cases came from didn't just look at these three events. It covered 5 major infrastructure breakdowns in a really short amount of time, including others at places like Azure and Vodafone. The point is, these massive failures, they aren't flukes. They're just part of the daily reality of keeping the global internet running. But here's the really fascinating twist. During the exact same week that all these huge events were happening, the total number of global outages actually went down, and by a lot. We're talking 42%. This chart shows it pretty clearly. Even as these huge, headline-grabbing failures were making all of our lives difficult, the internet as a whole was actually getting more stable. It seems like while the big failures are more spectacular, that background noise of smaller problems is actually going down. The whole ecosystem is constantly learning and adapting.
And that leaves us with one final big question. We build these incredibly complex systems for all the amazing things they can do. But does that complexity just create new, unforeseen ways for everything to fall apart? It's the paradox of the modern internet. As our digital world gets more and more powerful, are we also just building more elaborate, more fragile chains of dominoes, all just waiting for a single nudge? It's something to think about the next time your favorite app goes down. Thanks for joining me.